Hello everybody, sorry to not be in class today, but I know you're in excellent hands. Just wanted to go through the powers quiz so that you can see, I want you to have feedback fairly quickly so you can see where things went well, where you may need to work on things. And I'll find a way to get you your quizzes back shortly. So, number 1, write the following using repeated multiplication. Explain the similarities and differences between the two expressions using the words base, exponent, and coefficient. So for 1a, we have this negative in front of 4 to the power of 5. So the negative is not a part of the base. It's not going to be repeated 5 times. We're going to have the negative of 4 times itself 5 times. And for b, the difference is here that the negative is included in the base, okay, because it's inside brackets, and everything inside the brackets here is being raised to the power of 5. So this one here we should write out as negative 4 times itself 5 times. So I talked a bit about some of the explanation already, but the bases are different. Okay, the top one has a base of 4, and the bottom one has a base of negative 4. The exponents are the same. And I mentioned this word coefficient. So you might be able to say that question A or example A has a coefficient of -1 in front of the power. So I was really looking to see that you understood when the negative was included and when it wasn't. For number 2, that kind of plays in, the information from question 1 kind of plays in with this one here. Many of you did not include the negative in brackets to the power of 4. If you wrote negative 5 to the power of 4, that's not the same. It's not negative 5 times itself 4 times. That's 5 times itself 4 times, and then the negative of that. For number 3, simplify 12 to the power of 0. We talked about why and how anything raised to the power of 0 is 1. For 4, you're asked to simplify the following expressions and then evaluate. So 2 to the power of 3 times 2 to the power of 2. We have the same base, and we're multiplying them together, so we can add the exponents. If we wanted to prove it, we could show that we have 3 times 3 times 3, 2 times 2 times 2, times 2 times 2, and there's 5 of them there. So 2 to the power of 3 plus 2 is 2 to the power of 5. And if we evaluate that, 2 times 2 times 2, 5 times, we get 32. For B, we know that when we're dividing powers with the same base, we subtract the exponents. So 3 to the power of 7 minus 4 is 3 to the power of 3. And if we evaluate that, we get 27. If you chose to prove this one, you would write out 7 threes on the numerator. You would write out 4 threes in the denominator. And then we would show that 3 divided by 3 is 1, and they cancel out or simplify. And we're left with 3 to the power of 3. For C, same idea. We have 2 cubed to the power of 2, so we're multiplying this by itself, And when we do that, we're going to multiply the exponent. So 2 to the power of 3 times 2 would be 2 to the power of 6. And we can show that by writing this out. We have 3 2's here, and 3 more 2's here. And you can see how we have 6 in total. When we evaluate that, we end up with 64. So those are kind of some of the basic pieces that we really need to have a good understanding of before we move on. Number 5 was another question to check on your understanding of the negatives here. We have the negative of 5 to the power of 3, which is 5 times 5 times 5. And when we evaluate that, 5 times 5 is 25. 25 times 5 is 125. So we should end up with negative 125. Write 2 over 3 to the power of 3 as the quotient of 2 powers. So what we really want to do is we want to cube the top and cube the bottom. 2 to the power of 3 over 3 to the power of 3. And now we've written this as the quotient, division, of 2 powers. For number 7, very similar except for we're looking at the product. So I want you to show me that we would cube 5 and cube the negative 2. You did not need to evaluate. And number 8, last one on the first page, was to simplify. And I gave you this pretty messy situation, but I'm hoping that you noticed these brackets on the outside here show that everything inside of them, all of this, is being raised to the power of 0. And therefore this is just 1. I gave you a bit of a hint because I didn't give you very much working space there. So if you got all of those correct and you're on the right track, that's like showing me minimum understanding, the basics. That's a C-level situation. Don't worry, there's always lots of room for improvement. Page number 2. Bob needs help with his homework. Explain how to simplify and then evaluate. So I'll just do my explanation auditorially, if that makes sense, instead of writing it out. But first, we would simplify inside the brackets if we can. So 5 minus 2 is 3. And we have negative 3, nothing we can do on the right-hand side. I can now work with the exponents. So 3 to the power of 3 is 27. And this exponent, I don't really know how to evaluate this expression right now with the negative exponent, so let's rearrange it. Make sure you keep the negative 3 inside brackets and make it so I have a positive exponent. So 1 over negative 3 to the power of 2. Now this is 27 plus 1 over negative 3 to the power of 2. Negative 3 times negative 3 is 9. And you could write this as 27 and 1/9. I actually intended on this question to change this addition symbol to multiplication, but that's okay. If you chose to try and make a common denominator with things, that was fine as well. Number 10, write this expression as a single power. So I just want you to try and simplify as much as you can and write it with a power at the end. Starting inside the brackets, we have a to the power of negative 3 times a to the power of 2. So we will add the exponents because we're multiplying the bases. Negative 3 plus 2 is negative 1. Next step, we've simplified now inside the bracket so we can work with the exponents. And if I have a power being raised to a power, a to the power of negative 1 to the power of negative 3, that gives me, I multiply the exponents, power of a power, so negative 1 times negative 3 is a to the power of 3. And now I want to simplify between the numerator and the denominator of this fraction. So 10 divided by 5 is 2. And a to the power of 3 divided by a is a squared. So that's number 10. Just be super careful with your negatives and negative exponents. On to a number 11. Simplify as a single power. So you don't need to evaluate each of these pieces first. You should notice that they all have the same base. So a fraction line gives us a grouping symbol. So let's group the top and work with them first. Negative 3 to the power 5 times negative 3 to the power 6 means that we are multiplying powers that have the same base. So we add the exponents. That gives us 3 to the power of 11. In the denominator, 3 to the power of 7 times 3 to the power of 1. Multiplying bases again, so we add the exponents. 3 to the power of 8. Now, because we are dividing powers that have the same base, we are going to subtract the exponents. And we'll end up with 3 to the power of 3. Writing it as a single power stays like that. You don't need to multiply this out. And here we go. As I start talking about not missing your negatives, I missed all of them. So the base has not changed from the very beginning. It's still negative 3. And on to number 12. This one you have some options with how you choose to solve. There's lots of different methods as long as we stick within the rules. I look inside the brackets first and say, hey, is there anything I can simplify between these A, B's, and C's? And I don't see anything. Then I can see with the exponents, I could move the 2 in and square everything, and then I could multiply everything again raise everything again to the power of negative 3. But I could also simplify these exponents first. So we have a power being raised to a power, so we multiply the exponents. The base stays the same, and we now have an exponent of negative 6. Remember that everything inside the brackets has to be raised to the power of negative 6. Super important. You also have the choice here, if you wanted to get rid of this negative 6, you could do that. So I'm going to go 2 different ways. One way is to get rid of the negative 6, and we can do that by flipping the fraction. Then our exponent will be positive, and then we can distribute it in. So c to the power of 3 to the power of 6, we multiply the exponents, get c to the power of 18 in the denominator. Don't forget a has an exponent of 1, and a has to be raised to the power of 6. And b squared raised to the power of 6 gives us b to the power of 12. If you didn't change it so the exponent was positive, you would just move the 6 in, and you'd have a to the power of negative 6, b to the power of negative 12, all over c to the power of negative 18, and then we would have to move a down to the bottom to make its exponent positive, move b down to the bottom to make its exponent positive, and move c up to the top to make its exponent positive. Either way, you should get to the same solution. So those were all your B range questions. And if you survived those and you persevered, carried on, and you worked through the A range questions as best you could, you would have ran into number 13. This question here will hopefully let me check off the box I can make connections to other mathematical concepts. So this is a powers question, but it's within a geometry type question. The surface area of a cylinder is given here, where r is the radius of the cylinder and h is the height. The radius is 8 centimeters and the height is 8 centimeters. Use the exponent rules to write the surface area in the form of some number, 2 to the power of x, times pi. Well, there's a couple different ways you can go about this. Most people would just substitute in r, which is 8. So 2 times pi times 8 squared. And then we're adding 2 times pi times r, which was 8. and times h, which is also 8. And we can simplify this a little bit. So we have pi, which we don't really want to change. We have 2 times 8 squared. Well, 8 squared is 64. And we have 2 times 64, which gives you 128 times pi. And over here, we have the same thing. 2 times 8 times 8, which is 128 pi. And if we have 128 pi plus 128 pi, we end up with 256 pi. And if you're going to compare this to the way I wanted your answer, we have to rewrite this 256 as 2 to the power of some number. And then you could just work through the powers of 2 to find out what value that is. So 2 times 2 is 4. That's 2. And then to the power of 3 would be 8, 16, 32, 64, 128, 256. So we end up with 2 to the power of 8. The other way to work this question is, instead of writing 8 as the height and the radius, we could rewrite 8 as 2 to the power of 3. And if we did that, we'd have 2 times pi times 2 to the power of 3 plus, oh, and that's squared, plus 2 times pi times 2 to the power of 3 times 2 to the power of 3. And this is all because we can rewrite 8 as 2 to the power of 3. And now we can work on simplifying. So we have 2 times pi times, well, 2 to the power of 3 to the power of 2 is 2 to the power of 6 plus 2 to the power, or sorry, 2 times pi times 2 to the power of 3 times 2 to the power of 3 is 2 to the power of 6. And if we have 2 times 2 to the power of 6, I end up with 2 to the power of 7 pi plus 2 to the power of 7 pi. This last step is a little bit tricky. So we have 2 to the power of 7 times pi plus 2 to the power of 7 times pi. So I have 2 of these 2 to the power of 7 times pi's. And if I'm multiplying another 2 in, I end up with 2 to the power of 8 times pi. Yep, definitely a difficult question. Many of you got down to this place here and didn't quite know how to rearrange that last piece, and that's okay as well. So good work on that if you gave it a shot. 14, identify and then correct any errors in the work shown. So the original question is 3 to the power of 2 times 3 to the power of 3, all raised to the power of 2. In the question, you can see that they've simplified inside the brackets first, and they wrote 3 to the power of 2 times 3. But when we're multiplying bases, we would add the exponents of the two powers inside the brackets. So this should say 3 to the power of 2 plus 3 squared. Then when they simplify that, they would get 3 to the power of 5 all squared. And the next step, when they had the power of a power, they added when they should have multiplied. So this should be 3 to the power of 5 times 2, which is 3 to the power of 10. And I didn't care if you actually expanded this or not, but if you did, I think you got something like 59,049. On to 15. Simplify. So with this one here, we have two fractions inside the brackets, and I recommend you start by simplifying inside the brackets before you move the 2 in. So do not do that first. take some time and simplify inside, because there's a whole bunch of b's in here, and I bet you're going to be able to simplify them down to be less. So 4 b to the power of 3 times b to the power of 2 is b to the power of 5 all over b to the power of 3, still to the power of negative 2. And I'll just take this piece one step further. I can now divide b to the power of 5 by b to the power of 3, and I end up with 4b squared to the power of negative 2. On the right hand side, I can multiply the numerator, so b to the power of 4 times b to the power of negative 3. We would add the exponents. 4 plus negative 3 leaves us with b to the power of 1 all over 2b to the power of 3. Next step, we can simplify the values of b here. So b to the power of 1 divided by b to the power of 3. We'll subtract the exponents, and we end up with b to the power of negative 2 all over 2. Don't forget the 2 still stays there in the bottom. And now we can move our negative 2 in, or we can make it positive. Your choice. If you wanted to make this positive, you'd rewrite it as 1 over 4b squared to the power of 2. And we're multiplying that by, you could make this one positive as well. The way you would make this one positive would be by moving the b down into the bottom. So we would end up with 1 over, we have the 2 in the bottom, and it's not included in this negative 2. There's no brackets around, just b over 2. So the negative 2 exponent here is only attached to the b. So if we move it to the bottom, we get b squared. Something's frozen here. Okay, back in action. So b to the power of 2. And then we can multiply these two fractions together. So 1 times 1 is 1 all over. Oh, I haven't simplified this left-hand piece yet, so let's do that as well. So 4 squared is 16. B squared to the power of 2 is b to the power of 4 times 1 over 2b squared. Multiply the tops, we get 1. Multiply the bottoms. 2 times 16 is 32. Multiply the coefficients first. And then b to the power of 4 times b to the power of 2 is b to the power of 6. Now, if you chose to multiply the negative 2's in first, we'll go this way with it, you'd have 4 to the power of negative 2, b squared to the power of negative 2, and then multiplying that by b to the power of negative 2 all over 2. And then we'd rewrite this b to the power of, 4 to the power of negative 2 would be 1 over 4 squared. And here we would have b to the power of negative 4. And here we could move the b to the power of negative 2 down, or, yeah, we would have to move that down into the denominator. So we get 1 over 2 times b squared. And we can square 4 to get 16. This becomes 1 over b to the power of 4 when we make the exponent positive. And the last one, there's nothing we can do here. So multiplying all the denominators and numerators together, we end up with 1 over 32 b to the power of 6. Definitely a difficult question which required some perseverance and a pretty strong understanding of how to work with the negative exponents and ones that are exponents that have a fraction involved or are part of a fraction. Last but not least, number 16, insert the brackets to make this equation true. So this is a bit of a perseverance type question on order of operations. And if you played around with this for a while, you probably would have found that if you added brackets in here and here, we could simplify this. So 5 times 4 squared is 16 minus 3 cubed. So 16 minus, 2 cubed, which is 8. So 16 minus 8 gives us 8. And here, 3 to the power of 3 divided by 3 is 3 to the power of 2, which is 9. And we can check. 5 times 8 is 40, plus 9. Yes, that does equal 49. That's it. That's all. Don't stress over it. Take some time. On your copy, I've checked off the boxes on the left-hand side that you demonstrated to me throughout this assessment. You can come up to me and show me that you know these things in some other way if you'd like, and I can check them off and add them. Or you can do another rewrite on a second quiz another day. Lots of ways to improve on this. Hope that helps. Take care.